perspective of the overall building and the porch. There's a few different concepts that we could do with the porch, but I wasn't really sure on the laundry area if we actually wanted to cover that. So there's some conversations that we can have, and it's still conceptual. And then just actually about bringing the grade up, maybe potentially more conversations to have. But I did ventilation block back here rather than actually keeping that open with columns and stuff, partly because of structural reasons, but also I think it'll keep your laundry machines and all that kind of stuff a little bit safer in that concept. But really trying to introduce a lot of ventilation through this process.
I love that picture. Let me get that real quick. That inspires me.
So actually one of the other things too that because of needing to redo the foundations too and the footings, we're actually thinking about proposing moving the porch line to the old foundation line. So you push it north 3 meters, but that's still open for conversations for sure. So there's another great picture in the dining hall. I did get your TV in here. I put it back in the corner where you guys had it before. I would really like to try to get as many windows as possible, just because daylight's really nice and it's really good for the emotional impact of people too. So that's there's some balance there, I think. But there's also ample space above the windows too, so that's an option too with the placement of the TV. And also introducing vents up above too, just to allow the hot air to escape.
Okay.
And this is just another picture of the inside the kitchen. So just give a little bit of idea of that. And then another picture. So just kind of emphasizing the breezeway, so that it'll actually allow the air to pull through there and actually suck the hot air out. That's kind of where we're at right now. Hand it over to the structural team.
Right, I'm Stan, Elizabeth Berry, my cohort, partner in crime. Elizabeth did all the work on this. I was kind of like Nate. I spent most of my time at the pool.
All right, so our focus for this trip was to look at the local building design requirements, the materials, and construction practices, since we're very unfamiliar with what you have and what's available. It's different from what we're used to. And so we also took special notice into the spider trusses and seeing about the capacity and how they're used in construction.
And you found it unsafe.
Well, we found a different option. So we also took a nice little field trip down to go meet Michael as he makes the CMU blocks. And this was very informational. We got to actually measure the size of the real blocks instead of just going out and seeing. And we got to watch them make it. They do it all by hand, which is interesting. So we like the bigger blocks, how they make them better than the interior wall blocks. There was like some cracks as they're just taking out the few examples for the interior walls, and that's just this. We did get to see the bags. They give strengths on there, and so we got to see it and see what the company says it's going to be, but just for precaution, we are going to undercut that value a bit just after watching how it's made. So we were helping with the kitchen and dining room design. So we saw the spider trusses, saw that you would need interior columns, so we decided to try something new, just put an option out there. This is all steel, and so after talking with you about the way you could get the material here, there's no welding on site since that's not possible. It's all bolted connections. However, the truss is all welded and have to be carried. So we got a weight for you. It's about 640 pounds, which is a little heavy, but there's lots of guys who I think would be happy to do that.
Oh yeah. We'll just build the pyramids again.
Yeah, so we also have take-off spreadsheet and for what materials you need and minimum sizes. We know what's available for you is not what is in our design programs. So we just put like minimums so that way you can be like, okay, this or better.
Okay.
Whatever is available for you. So we also got the chance to meet with Julius, the architect, which was very fun, very interesting. He told us about different design codes. He says he has a soft copy, still waiting on it, but send him a reminder email.
Okay.
So we got to talk about different construction practices and design practices and the process for getting things permitted, which was also very interesting. Expedited is 30 days, but that's like 100% increase in cost, or else like 90 days, which, I mean, works and is cheaper. So this was very informational. We got a lot of things, and so from here we're ready to do more now that we'll have like the local codes and requirements to get things permitted. So I'll give it to you for the recommendation. There you go. Stand. You have to go through each one.
What? Oh, okay.
So, as structural engineers, really, the bulk of our time spent here was information gathering. We need to understand what the constraints are, and there are significant constraints from what you have material-wise and what you have construction-wise. And we don't want to barge in and say, hey, you need to do it this way. We need to understand how can you do it and what makes economic sense. So instead of coming in and proposing this is the way we do it in Colorado or whatever, we are making a few suggestions on incremental changes to design that would improve from an engineering standpoint what the local practice is. So that is what is represented here. So some of the incremental changes, and this is a bunch of text here. You're going to read this, you're going to say, oh, what's that? So there will be details coming with this. But basically what this one is saying is that my understanding from our conversation was that at the top of the footing, they would just sit the foundation wall on it and build up, and there wasn't really there's nothing going across the interface. So that's one thing that could help. We were searching for seismic or earthquake information, and it's all anecdotal. Some of the maps that we got indicated that it's actually a moderate earthquake risk here at Terra Nova Farm. So that's why we think like it's important to start taking that into account. And this one, adding vertical steel dowels across the interface of the footing and the bottom of the foundation wall. And these would be our number 4 bars, 1/2-inch diameter, number 13 metric. And they're at about 30 centimeters horizontal, so that's every foot.
Right.
A number 4 bar up there every foot. So that's just an incremental change that you might consider, and probably, when what will happen, we're really happy that you probably are going to get Julius involved in this, and he'll get a structural engineer. But in order to get those approved drawings, I think they're going to have to do this anyway. Another one of the incremental changes below the foundation, and I know that you put rocks down the cells and that type of thing, but you might want to consider doing fully grouted in the cells just up to get it above grade. Again,
When you say grout, what does that mean?
well, it's mortar, or it's concrete mix with not having the large aggregate. Basically, it's sand as your aggregate. So it's close to what mortar is, but that'll just give you better continuity in your structure. And I'll have to admit, I have to confess, we went down and we saw Michael, and we said, yeah, okay, it looks fine, but we have no way of knowing really what the quality is until it's tested. So you saw the CMU blocks out here by the entrance when we walked in. I don't know if you noticed those or not. They were sitting on the ground. I reached over and tapped one with toe of my foot and it broke.
It's the-
So
Yeah. it's-
that's why I, rather than just trust plain CMU, I think we probably better do some things like this to make it stronger.
Right.
So I don't know how much that costs, but I owe them. You can see it, it's the one in the corner, go out there, you'll see it. Tap it with my foot, it broke.
Oh, yeah,
So-
we did that, we picked up a load of things from here at one time, and by the time we reached Terra Nova Farm, half of them were in sharp, in just,
Yeah.
and that was just driving on the street,
Yeah.
that was not like bouncing over cars.
It's the quality.
Yeah, so,
There's only 2 cement factories in the whole country.
I think that also had a lot to do with their mix, they skimp on the cement by
Some of them,
having
yeah.
Instead of 3 to
sand.
1, they do
cement is the
And
most
unless you're
100
there to
ones.
watch them, then.
So we've got pictures of the bags they were using to mix and what the different mix ratios are and supposedly what the strength that you get out of it. But that's what Elizabeth was saying, we're not gonna take that, we're probably, we would need to not count on as high a strength. This one is just another one of those, kind of has to do with what we've been talking about. From my understanding, right, the current practice is basically unreinforced, except for horizontal every second course.
Yes.
But we would recommend adding, and again, number 4, a 1/2 inch diameter, number 13 metric, in a fully grouted cell. So that's you put the bar in there, and then you force it's a concrete mix down, and that'll give you better continuity up the wall.
So how that goes up like I guess you do it every because if you have like a 12-foot wall,
We're talking vertical.
but
Trying to get it down.
Yeah.
Yeah, you'd come up from the foundation and you'd leave a dowel sticking out
about a
above
foot,
the
couple feet or
foundation
something.
wall, and then you can lap down, you can push down through the cells.
Right.
Of course, your cells are not open on the bottom, but you might have to
Well, it's
punch
pretty
through
thin.
that. Yeah, you can punch through that.
But can we do it like in increments together? It has to be
You
one,
could.
one piece.
No, you
can I
could.
do it like a 4 feet
You could
piece,
lap it.
stick it in there,
Yeah.
tie it up, and
Yeah.
then have the next piece and do another
Yeah.
4? That would make it a lot easier.
Yeah, and we call that a splice length.
Right.
You'd have to overlap it, but,
Right. And
yeah.
just wire will be fine.
Yeah, yeah, you can do
Good,
that.
that would be
So, and this is about 4 foot spacing, every 4 foot,
120 centimeters?
120 centimeters, isn't that about 4 feet? I think it is.
Yeah.
Yeah, okay,
Okay.
yeah, so about, one of these going up.
Okay.
And I see the dollar signs,
Because that's a huge.
it is,
You're gonna
yeah.
have a lot of rebar, but that's gonna strengthen. That'll give me.
Yeah, and I'm glad I tapped that brick out there. That makes me a little more comfortable.
Okay.
Extra.
Let's go for it. Let's do it different.
Well, does
And
that help to reduce, you saw so many of our walls have, the cracks.
yeah,
Is that what's gonna stop that from happening?
there'll still be some diagonal cracking, but it will help. But I don't think we'd undertake that away without doing significantly more reinforcing. And even then, in concrete construction, you expect cracks.
It's no matter what,
Yep.
it's gonna happen.
Yep. Yeah, you're gonna see them. That's just whether they're safe or not.
Right. Okay.
So this was our, the joist that we designed, and we designed it so you wouldn't have to have columns in your in your dining area. And overnight, I'm kind of struggling with the way that we did it. Frankly, 640 pounds. What that was based on is our understanding of what could be manufactured locally, and we wanted to keep it horizontal, keep it simple for construction. We may want to rethink that, and what that would mean is